Hello students, welcome. Previously, lesson 6, we have done the first part of nitrogen peroxide gas, where we have done the laboratory preparation of nitrogen peroxide gas and the physical properties of nitrogen peroxide gas. So today, lesson 7, we'll be proceeding to the second part of nitrogen peroxide gas, and in this lesson, we are going to do number 1, chemical properties of nitrogen peroxide gas, and number 2, the uses of nitrogen peroxide gas. So kindly stay with us until the end of the video. So to start the first part of our class, that is chemical properties of nitrogen peroxide gas, we are going to start number 1, reaction of nitrogen peroxide gas with water. And we are saying nitrogen peroxide reacts with water on dissolving to form a solution which contains nitric 5 acid and nitric 3 acid. And we are saying the solution turns blue, litmus paper red. So the question for that reaction will be 2 moles of nitrogen peroxide gas reacting with 1 mole of water, which is liquid. What we are going to get is 1 mole of nitric 5 acid and 1 mole of nitric 3 acid. Remember, nitric 5 acid is also known as nitric acid, while nitric 3 acid is known as nitrous acid. So we're saying if the solution is shaken vigorously with air, the nitric 3 acid is oxidized by oxygen in the air to form nitric 5 acid. And the question for that reaction will be 2 moles of nitric 3 acid solution plus 1 mole of oxygen gas. What we are going to get is 2 moles of nitric 5 acid. So number 2, reaction of nitrogen peroxide with burning substances, and we are saying nitrogen peroxide does not burn or support combustion, because the only gas that supports combustion or burning is oxygen gas. So we are saying, however, it decomposes to nitrogen 2 oxide and oxygen at high temperatures, and the question for that reaction will be 2 moles of nitrogen peroxide gas, which are red-brown vapor, or which is red-brown gas. When it is heated at high temperatures, it decomposes to produce 2 moles of nitrogen 2 oxide gas and also 1 mole of oxygen gas. And remember, both nitrogen 2 oxide gas and oxygen gas are colorless gases. So we're saying next, vigorously burning substances, e.g. magnesium, phosphorus, and sulfur will continue to burn in nitrogen peroxide gas. And the reason being, we're saying this is because the temperatures produced are sufficient to decompose nitrogen peroxide into nitrogen 2 oxide and oxygen. And we say next, the nitrogen 2 oxide is decomposed further into nitrogen gas and oxygen. Then we're saying the burning substances are oxidized to their corresponding oxides, and nitrogen peroxide is reduced to nitrogen gas. So here, when we're dealing with this reaction of nitrogen peroxide with burning substances, we can see the oxidizing power of nitrogen peroxide, because nitrogen peroxide oxidizes these burning substances into their corresponding oxides, while itself gets reduced to nitrogen gas. So next, let's proceed and see the questions. We're going to start with magnesium. So 4 mole of magnesium solid will react with 2 mole of nitrogen peroxide gas, and what we are going to get will be 4 mole of magnesium oxide solid and also nitrogen gas. So in this reaction, magnesium will be the reducing agent because it reduces nitrogen peroxide into nitrogen gas, while itself gets oxidized to magnesium oxide. The oxidizing agent in this reaction will be nitrogen peroxide because it oxidizes magnesium to magnesium oxide, while itself gets reduced to nitrogen gas. So what are the observations made? So number 1, we are saying the magnesium metal continues to burn in nitrogen peroxide, and number 2, a white solid is formed, and that is due to the formation of magnesium oxide. The next, red-brown vapor fades. Remember we said the color of nitrogen peroxide is red-brown in color, but when we see the product that we have gotten, nitrogen gas is a colorless gas. So that means the red-brown vapor will fade, it will disappear. So the reason for these observations, we are saying the heat from burning magnesium decomposes nitrogen peroxide into nitrogen and oxygen. We are saying therefore the oxygen produced supports the burning of magnesium and reacts with it to form a white solid, which is magnesium oxide. And we are saying nitrogen gas is also formed, which is a colorless gas. So next, let's see the reaction between sulfur and also nitrogen peroxide. We are going to have 2 moles of sulfur solid reacting with 2 moles of nitrogen peroxide gas. What we are going to get is 2 moles of sulfur peroxide gas plus 1 mole of nitrogen gas. So next, if we are dealing with maybe phosphorus, we are going to have 2 moles of phosphorus, which is solid, reacting with 10 moles of nitrogen peroxide gas. What we are going to get is 4 moles of phosphorus 5 oxide and also 5 moles of nitrogen gas. So next we are saying nitrogen peroxide extinguishes a glue in a splint. The reason is that because we are saying the temperature of the splint is not sufficient to decompose the nitrogen peroxide. So next, let's proceed to the third chemical properties of nitrogen peroxide, and that's reaction of nitrogen peroxide with heated metals. And we are saying nitrogen peroxide oxidizes copper and iron to their corresponding oxides and itself reduced to nitrogen gas. So the question for that reaction, we are saying 4 moles of copper solid reacting with 2 moles of nitrogen peroxide gas. What we are going to get will be 4 moles of copper 2 oxide solid and also nitrogen gas. So the observation made, number 1, we're saying red-brown solid changes to black, and that's due to the formation of copper 2 oxide. And number 2, we're saying red-brown vapor fades because here we're having nitrogen gas which are colorless. So that means the red-brown vapor fades or it disappears. So the reason for that observation will be, we're saying copper reacts with nitrogen peroxide to form black copper 2 oxide and nitrogen gas, which is colorless or a colorless gas. So we're having next iron reacting with nitrogen peroxide. 4 moles of iron solid will react with 2 moles of nitrogen peroxide gas. What we are going to get will be 4 moles of iron 2 oxide solid plus 1 mole of nitrogen gas. So let's proceed to the fourth chemical properties of nitrogen peroxide gas, and that is reaction of nitrogen peroxide gas with alkalis. We're saying nitrogen peroxide reacts to form a mixture of nitrate and nitrite salt in equal amounts. For example, with sodium hydroxide, it forms a mixture of sodium nitrate and sodium nitrite. Remember, water is also produced as one of the products. So the question for that reaction, we are going to have 2 moles of nitrogen peroxide gas reacting with 2 moles of sodium hydroxide solution. What we are going to get is sodium nitrate solution plus sodium nitrite solution plus water, which is liquid. So we're saying this happens because nitrogen peroxide reacts with water to form a solution which contains nitric acid and nitrous acid. Remember we said nitric acid is nitric 5 acid and nitrous acid is nitric 3 acid. And we're told each of these acids reacts with sodium hydroxide to form the corresponding salt and also water. That's why we're going to get sodium nitrate, sodium nitrite, and also water. Next, let's proceed to the fifth chemical properties of nitrogen peroxide, and that's thermal dissociation of nitrogen peroxide. We are saying when nitrogen peroxide is cooled to below 0 degrees Celsius, it condenses to form dinitrogen tetraoxide, which is a pale yellow liquid. When nitrogen peroxide is heated above 150 degrees Celsius, we are saying it decomposes to form nitrogen 2 oxide and oxygen gas, which are both colorless. This can be represented as follows. So here is the starting. We're having nitrogen peroxide gas. If we cool it to a temperature below 0 degrees Celsius, we are saying it condenses. If we cool it, it condenses to form dinitrogen tetraoxide, which is written N2O4, which is liquid. So its color is pale yellow liquid. So if we heat it, that means if we take this nitrogen peroxide and we heat it, what we are going to get is nitrogen 2 oxide and also oxygen gas, which are both colorless. That's why we are saying when nitrogen peroxide is heated above 150 degrees Celsius, it decomposes to form nitrogen 2 oxide and also oxygen gas, which are colorless. So next, let's proceed to the second part of our class, that is the uses of nitrogen peroxide gas. Number one, we are saying it's used in the manufacture of nitric 5 acid. Number two, it's used as an intermediate in manufacture of explosives, nylon, and also plastics. Number three, it's used as an oxidizing agent in the lead chamber during the manufacture of sulfuric 6 acid. Remember, learners, during the exam you can be asked, state the main use of nitrogen peroxide gas. If you are asked about the main use will be number one. The main use of nitrogen peroxide is it is used in the manufacture of nitric 5 acid. And that's the end of our class today. Thank you for watching.